Welcome to the course Depreciation, Alternate Investment and Profitability Analysis. We are continuing with the module 3, which is profitability analysis, and this is the last lecture in the series of 20 lectures. Here we will discuss the RACE profitability analysis methods under discounted cash flow. In the discounted cash flow methods are a set of methods which use time value of money. Following discounted cash flow methods will be discussed: discounted cash flow of return or internal rate of return IRR, terminal value TA method and profitability index. Now, let us see the formula of discounted cash flow of return or internal rate of return. The discounted cash flow of return or internal rate of return is defined as the discounted rate, interest rate R, which makes the sum of the present value of the cash inflow equal to the sum of the present value of the cash outflow. IRR can be computed from the expression of NPV, which we have already seen. So, this is the NPV equation. Now, if I put 0 in place of NPV, that means the value of I, if I put value of I is equal to R, then this equation, this left hand side of the equation becomes 0. So, IR can be computed from the expression of NPV, the value of I, say R, which makes NPV 0 is called IRR, that is internal rate of return. Now, with the examples we will do this, so it becomes more clear to you. The IRR can be used as a accept or reject criteria for a project. For doing so, the IRR calculated is compared with the required rate of return, also known as cutoff rate or hurdle rate. The project is acceptable if IRR exceeds the cutoff rate. Now, let us take this first example. The objective of this first example is find out the internal rate of return for a given cash flow of project. Now, the initial cost of the project is initial cost of the project is 75,000. Find out the internal rate of return. So, I have to find out what is IRR equal to R, what is the value of R, which will make the NPV equation equal to 0. Now, what are the cash flows available after tax? This is year. So, this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 1, 3, 5, 6, 9, 1, 4, 6, 5, 9, 1, 5, 8, 7, 6, 2, 7, 86. And if I do the sum, this is 7, 7, 2, 3, 5. Now solution. So initial cost of the machine was 75,000. So as this cash flow in the timeline at t equal to 0, this cash flow takes place 75,000. So this is the present value, we have not to change this because this is the present value, whereas the cash inflows here we have to convert them to the present value. Now if I use R is equal to 0.2, then these values will, and try to convert this. So this will be converted for R equal to 2, this will be 1, 2, 3, 4, 5 into 1 by 1.2 to the power 1. This comes out to be 1, 2, 3, 4, 5 into 0.8333 comes out to be rupees 10287.5. Now similarly for R equal to 2, if I calculate this one, this comes to be rupees 9422.92. This comes to be rupees 8483.22. This will come rupees 7656.25. 7656.25, and this comes as rupees 8353.43, and if I sum this, this comes up to 44203.32. So what I find that if I am taking R is equal to 2, that is 20%, this value is 44,000, whereas my initial cost is 75,000. So the present value of the cash flow is less than the cash outflow, hence the value of R should be increased. Now if I am going for 70, if I am going for R is equal to 0.221, then I am getting these values 10110.6, 13569.0, 14659.0, 15876.0, 20786.0, and this comes out to be 75,000.6. So if I am taking this to be R value is to be 0.221, this value matches with this value. That means the difference is 0. For the present problem, when I take R is equal to 0.221, that is 22.1%, the sum of present value of the cash inflow becomes equal to 75,000.6, which is almost equal to the cash outflow, which is 75,000, and thus the internal rate of return IRR for this problem is 22.1% or 221. This is my answer. Now let us take terminal value TA method. TA method assumes that each cash flow is reinvested in another asset as a certain rate of return, and this rate may be different than the cost of capital from the moment it is received till the termination of the project. the accept reject rule for TA method is that if the present value of the sum of the reinvested cash inflows under compounded interest is greater than the sum of the present value of the cash outflows, then the project is accepted, otherwise rejected. Now, the objective is, given the initial investment, lifespan of the project, cost of the capital, yearly cash inflows and expected rate of interest on cash inflows, if it is invested, find out the sum total of the compounded interest cash flows and its present value. Further, by taking into account the present value of the cash outflows, take a decision whether to accept the or the reject the project. Now, let us take the example number 2 to demonstrate this. Basically, what it is doing, now we take example number 2, the initial cost rupees 1 lakh. I think this is lifespan of the project is 6 years, cost of capital is 15%, interest on reinvested cash is equal to 8% for first 3 years and 9% for rest 3 years. Now, if you see the cash flow after tax, if this is the year, this is 1, 2, 3, 4, 5, 6, and if this is the rate of interest, for first 3 years I have 8% and for the next 3 years I have 9%. This is the question. Now, if I want to make you understand what is the difference between the earlier one and this, in the timeline t equal to 0, I am sinking some amount, here in this case 1 lakh, and then each year I am getting some value, like here 45,000, 46,350, 48,324, 45,320, 42,356, 40,234. So, this value is 45,000. This value is 46,350, and this is the end of my period. Now, cash flow, if the cash flow of the first year is invested up to end of the project. Now, if this amount is invested and the interest is taken up to the end of the period, that means it will earn interest up to this. Now, how many years in the first year? This is 1 year, 2, 3, 4, 5. This will be invested for 5 years, and how I arrive at 5? This is 6 minus 1 is equal to 5, and for this is 6 minus 2 for 4 years, for this 6 minus 3 equal to 3 years, for this 6 minus 4 equal to 2 years, and for this 6 minus 5 is equal to 1 year, like this. So, this will earn money when it will be invested, and then I add up all the final values, and then the whole final value is transported back to this. This is the method. Now, let us see this physically how I am doing. So, the first investment will grow up to 5 years. So, my this investment will grow with 8%. So, this will be 45,000 into 1 plus 0.08 to the power 5, and this comes out to be 6619,119.76. Now, similarly, this one will grow 46350 into 1 plus 0.08 to the power 4, and this will grow to 63058.66. So, these values will grow, this will grow to 60874.32, this will grow to 52861.25, this will grow to 45,744.48, and this will grow because here this will be 0. So, the same value will go, it will be 40234, and when then add them up, the sum is 328892.5. So, in the time value, so this is t equal to 0 at 6 years, all these values are invested up to 6 years. So, when I add them up, then this addition gives you 3,28,892.5, this value. Now, this value has to be taken back here, that means present value of this value. So, the present value of the compounded sum of cash flow, the present value of the compounded sum of cash flow is equal to 328,892.5 into 0.432328 is equal to 142189.3. So, when it goes here, it becomes 142189.3. This is 1,42,189. Now, this value is more than the present value of the investment, and hence this project is accepted. As 142,189.3 is greater than 1 lakh, the project is accepted. So, this is the answer. Now, we go for the third method, which is called profitability index. PI is yet another DCF method. It is similar to NPV approach. It measures the present value of the return per rupee of investment and can be given as PI is equal to present value of cash inflows divided by present value of cash outflow. The accept reject rule for PI is, if PI is greater than 1, the project is accepted, otherwise rejected. For PI greater than 1, the NPV is positive, while if it is less than 1, it is negative for PI less than 1. Now, the objective 3 is for this PI. It tells, given the initial investment, cost of capital, yearly cash inflows, find out profitability index and take a decision whether to accept or reject the project based on PI. So, here the example number 3 is devoted to this PI method. To find out the discounted cash flow present value of the two different machines from the data given. So, cost of capital given is 10%, initial cost of machine A is 10,000, initial cost of machine B is 13,000, and cash flow after tax machine A, machine B, 1, 2, 3, 4, 5, this is 2460, 3256, 3326, 2156, 5210, 1980, 2678, 8769, 7650, 4302. Now, if you calculate the present value of this, because this, if you see the machine 1, this is the timeline, machine A, 1, 2, 3, 4, 5. Now, here the payment is 5210 and here the payment is 2460. So, what we have to do, we have to find out the present value of all this. And then add it up. So first year investment, cash flow, present value of cash flow, after tax Now, if we calculate here the first year cash flow, present value of first year cash flow will be equal to 2460 divided by 1 plus R is equal to 2460 into 0.909 is equal to 2236.14. So, this will be machine A, machine B, this is 2236.14. Similarly, PB of second year cash flow is equal to 2460 divided by 1 plus R whole square. This is equal to this value is 3256 into this comes out to be 2689.46. Now, if I calculate for these two, so I can note down this is 2236.14, this is 14, this is 2689.456, 2497.826, 1472.548 and 3235.41, and total comes out to be 131.38. Similarly, if I convert this becomes 1799.82, 2212.028, 6585.519, 2682.724. I missed something. There is a entry here 5224.95, and if I take the sum, this is 18,505.037. So, once we have calculated all this for the machine A is equal to this value 12131.38 divided by this value 10,000 comes out to be 1.213, and PI for machine B is equal to 18505.04 divided by 13,000 comes away 1.423. As PI of the machine A and B both are greater than 1, both machines can be selected, or we can take the B machine if you want more profit. Now, to summarize, the resource required to carry out a project are often less than that available for it. Hence, all investment must be carried out carefully and should be evaluated towards its economic feasibility based on some profitability analysis. In the present lecture, we have demonstrated the internal rate of return, net terminal value and profitability index methods, which are discounted cash flow methods, time adjusted, and we have selected a number of examples to show how this method works. I hope you have enjoyed this lecture series which are on engineering economics. Good luck. Thank you.